Students, this is a teacher summary for Unit 3, Lesson B, Similarity Shortcuts. You want to be on the right-hand side of your reference sheet that you just got. So we learned last time that similarity means basically things that have the same shape or a different size. The technical definition is similar shapes have congruent angles and ratios which are equal. That means you have 3 pairs of congruent angles and 3 pairs of equal side ratios. In other words, you have a total of 6 pairs of items when things are similar. But what we're going to be looking at today is the fact there are shortcuts. If there's a 2 or 3 combination of items, then you can say the rest are also similar. There's a minimal number of things. Instead of all 6, you only need these 2 or 3, and it makes shapes similar. The first one is this. If you have 2 corresponding congruent angles, then the triangles are similar. 2 corresponding congruent angles, then the triangles are similar. If we had 1 pair of congruent angles and another pair of congruent angles, 2 pairs of congruent corresponding angles, corresponding meaning the same position, we would say these triangles are similar. Same shape, different size. Another common thing that you should watch out for this is called angle-angle similarity, is this situation. Let's say you have parallel lines or 2 right angles here, which forces these to be parallel. Well, in this case, you have these 2 triangles are actually overlapping. You have this outer triangle, green one, and you have this inner triangle, the red. And both the red and the green have 1 right angle, so that makes 1 pair. But they also share this overlapping triangle right there. So if I pull them apart, it looks like this. There's our larger and our smaller. They have right angles, and then they both share that, I call it the toe angle. That makes these triangles similar. Same shape, different size. Take a moment and write that down. Another shortcut says this. If you have 3 equal side ratios, then the triangles are similar. Let me give you an example. Let's say this triangle here has a side length of 3, a side length of 4, and a side length of 5. And this one over here has a side length of 6, 8, and 10. If you compare our ratios left to right, we see that 6 to 3 is a 2 to 1 ratio. 8 to 4 is a 2 to 1 ratio. And 10 to 5 is a 2 to 1 ratio. The ratios are the same all the way around. So I'm going to put a little S here. I have a pair of side ratios, a pair of side ratios, and a pair of side ratios. So we call this side, side, side similarity. Just like up here, I have a pair of congruent angles, a pair of congruent angles. We call this angle-angle similarity. So we have angle-angle similarity and side-side-side similarity shortcuts. Last one says this. Let me give you an example. Let's say here this was 3 and this was 6. And let's say this was 5 and this was 10. And let's say we had this angle squeezed between, also congruent. So this shortcut says this. If you have a pair of equal side ratios, a congruent angle, and then another pair of equal side ratios, then the triangles are similar. So here, 6 to 3 is 2 to 1, 10 to 5 is 2 to 1. So here we have a pair of congruent side ratios. Then, squeezed between the sides is we have a pair of congruent angles. And then 10 to 5, it is a 2 to 1 ratio. That's another side ratios which are equal. So this last one's called side angle side similarity. So we have 3 shortcuts to similarity. Angle-angle similarity, side-side-side similarity, where you have 3 equal side ratios, and side-angle-side similarity, where you have a pair of side ratios equal, a pair of congruent angles, and another pair of side ratios equal. Keep this handy as you flip over to the teacher example. So now I'm going to teach you how to follow something called GIF. GIF. Given, implied, freebies. GIF. This keeps track of how to mark diagrams. Very important you follow my directions right now. And you mark up the diagrams as I direct. We're going to first learn how to mark given information. So we're noting information which is directly provided on the diagram. You're just noting it. You circle it, you make some sort of note about it, and you physically mark it up on the diagram. For example, right here on these diagrams, let's take a little summary of what we notice here. We see the short side here, so I label it short and I compare it to the short side here. So short to short, from 12 to 8, I know 4 goes in here 3 times and 4 goes in here twice. Now 16 is the longer side here and 24 is the long side here. We ask ourselves what goes into both of these. And of course 4 does, but also does 8. You want to choose as long as possible. And 8 goes in here 3 times. And 8 goes in here twice. Oh, lo and behold, the ratios are equal. And we notice that the angles are congruent. So we're noting given information here. So I'm going to put this here. I have a pair of side ratios equal. I have a pair of angles congruent. And another pair of side ratios equal. So I write down, what do I notice? I have an equal side ratio, which was 12 to 8, which became 2 to 3. I'm going to wait for you to copy that down. And then I had a pair of congruent angles, the 50s, 50 degrees for both. Then I had another pair of equal side ratios, which was 24 to 16, which became 2 to 3. And on the side, a pair of equal side ratios, a pair of angles, equal side ratios. We know these triangles are similar by side, angle, side similarity. That's how you note given information. Look at all that information that I'd like you to document. You just make note of what is given. That's it. On the right-hand side, I'd like you to take a minute and document it thoroughly, marking on the diagram and listing below what kind of given information do you possess there. Go. Let's see what you documented. Again, you're just making note of given information. So here, the given information is, we find the short side here. I'm just going to write S for short. And then we come over here, the short side here, and we compare. 2 goes in here 7 times. 2 goes in there 5 times. We come here, the medium side, and then we compare that to the medium side. And let's see what goes in both. 3. 3 goes in here 7 times, and 3 goes in here 5 times. And then we come, you should have mentioned the long, and you went to the long. And 4 goes in here 7 times, and 4 goes in here 5 times. So what do we notice is these 3 things. We have one set of ratios, which is 14 to 10, which becomes 7 to 5. Then we have another set of ratio, which is 21 to 15, which becomes 7 to 5. And then we have 28 to 20, which reduces 7 to 5. So we have 3 side ratios equal. Side, side, side. So these are shortcuts similar by side, side, side similarity. That's called given. All you do is you notice the given information and you document it and mark it on the diagram. That's given. Now, implied. Implied is information that is true because of the given. Because you have given information, you ask yourself what also is true. You want to specifically look for these 3 things when you're dealing with implied. The first and most important is when lines are parallel, you're going to look for armpits of the Z. When lines are parallel, you want to look for armpits of the Z, better known as alternate interior angles. And these, of course, are congruent. Next thing you want to look for is when lines are parallel as well, to watch out for corresponding angles. One's in, one's out, same side. And they are congruent. And then don't forget the simple truth that triangles add up to 180. So if you have a triangle, it's implied that triangles add up to 180. So I look at this diagram, and all I'm told is lines are parallel. That doesn't necessarily give me something directly congruent, but indirectly, what's implied by that is armpits of the Z. So because these are parallel, I can go like this, and these alternate interior angles are congruent. And technically, I could also go this way. Trace with me. Armpits of the Z are congruent this way. So that's the idea of implied. I was not directly told angles were equal, but because I was told the lines were parallel, it was implied that alternate interior angles are congruent. On the right-hand side, I'll give you just like 30 seconds. What is implied to be true in this case? Oh, on the left, because I have two pairs of angles congruent, I can call this angle-angle similarity. They are similar, same shape, different size, because of that shortcut. You try the one on the right. Okay. The one on the right, you should have caught the fact that triangles add up to 180. And you should have found here that this is 75 degrees and this is 75 degrees. And the fact that now we have all three angles congruent, so we know that this is also angle-angle similarity. So again, implied information is that which is true because of the given. That's implied. Given, implied. The last one you need to watch out for is what I call freebies. Freebies is marking information that's true even if it's not in the given or implied. It's like an automatic given. And the most common freebies you need to watch out for are, of course, vertical angles. If you see them, you want to mark them congruent. And when you mark angles congruent, put a little A for angles. I'm blowing this one up. So vertical angles is one. Or take a close look here. I have overlapping triangles. Let's draw them and pull them apart. This is H, L, and I. And then here, green. This is H, K, and J. And then these sides were parallel. So another common freebie is the fact that if you look really carefully, this blue and this green triangle, they overlap at exactly the same angle. That's called a reflexive angle, or an angle that is shared, reflexive, shared. So in this case, we would say angle H is congruent to angle H. That looks a little strange, kind of like a reflection in a mirror. That's why it's called the reflexive property. So when you have an angle that is shared, exactly shared, we say it's congruent to itself. That's another freebie. You want to mark that down. I'll give you a few seconds to do that. So here's an example here. You want to watch out for freebies. I look at this diagram and I see I have overlapping triangles. So there's my blue triangle. And here's my overlapping green triangle. And I see that these triangles exactly share this angle out here, right there. So we would mark that congruent. And then you put a little A for angle, meaning I have a pair of congruent angles. That's it. A freebie. It's there. You can mark it. There's no other given information. You try the one on the right. Look for a freebie and mark it. You should have marked the vertical angles. And whenever you mark a pair of angles congruent, put A for a pair of angles. That's a freebie. You see it, mark it. Now let's pull these three things together, and I'm going to show you how to use similarity shortcuts in something called a flow chart. So taking a look at this one on the left, I'm going to walk through given, implied, freebies and mark it. So given, implied, and freebie information. So let's look at our given information first. Our given information is the fact that we have a short side here. I'm just going to put short, and I compare it to the short side here. And I see 7 goes into both. 7 goes in there 3 times, and 7 goes in there twice. So I have, and then I see that I have given a pair of angles congruent. And then here, my longer side here, and my longer side here, 8 goes in here 3 times, and 8 goes in here twice. Notice it's the same ratio. There's nothing really else implied here, so that's our given. We've implied. There's no vertical angles or reflexive sides, so we're done with that. Now we're going to document, and we're trying to see why these triangles are similar using one of these 3 shortcuts: side, angle, and side, side similarity. So let's look at what we have in this first one. First off, I have a pair of 14 to 21 sides, so I'm just going to write 14 to 21, which equals a 2 to 3 ratio. And where do I get that information? It's given, so I'm just going to write because it's given. And that gave me a pair of side ratios equal. So I put an S for side ratios equal. Then I made note that this angle here, angle C, is congruent to angle H. And why do I know that? We just write because it's given. So that is a pair of angles congruent. And the last one I see, I have a 16 to 24 ratio, which reduces to 2 to 3. And how do I know that? It was in the given information. That gives us another pair of side ratios equal. So with these 3 pieces of information, I can say, oh, the shortcut I'm working with here is this one, side, angle, side. So I can say that triangle FAE is similar to triangle. Notice I started with the long side, so I have to start with the long side here. ECD, they're similar. And the reason why, I'm going to put it right at top, the reason why is because of side, angle, side similarity. I'm going to wait for a moment for you to copy that down. Now I want you on the right to try to document the given, the implied, and the freebies, and tell me why those triangles are similar. I'm going to give you a minute to do that. Okay, let's see what you guys came up with. Okay, so we see here that we have parallel lines. Therefore, it's implied that you have alternate interior angles congruent. Now, you could have gone this way, or you could have gone this way. Either way would not have mattered. So in this first one, you could have said E and C are equal, or you could have said angle A and D are equal. Either way would have worked. I'm just going to go with the first set. So I can say angle A is congruent to angle D, and the reason is because we are given the fact that we had parallel lines, because of parallel lines. And then you also can mark a freebie here. We have vertical angles right in here. So I can say angle ABE is congruent to DBC. Another device you could have used is you can always just add numbers if you want. We could have called this angle 1 and 2 to make it equal. Or make it easy, excuse me, angles 1 and 2 if you want. And the reason for this was because of vertical angles. Now look carefully at what we have here. We have one pair of angles congruent and another pair of angles congruent. So we can now say that the triangles are similar. Triangle ABE is similar to triangle DBC, and the reason for this similarity is because of the angle-angle similarity shortcut. These are called flowcharts. They give both the how is in the boxes and the why are right outside, so they answer both questions, the how and the why.